All right, section 4.3 talks about polynomial division, and we're going to learn two types of division. We're going to do long division, and we're also going to do synthetic division. And we're going to focus more on synthetic division because our goal here is going to be to factor these polynomials into linear factors. And synthetic division is really easy to do with linear factors. But long division is necessary if we have nonlinear factors. So I'm going to show you an example of that. When we do polynomial long division, there's several ways that we can see the question written. We could have it written as a fraction, and this represents division. It could be written sideways, where it says f of x divided by g of x. That also means the same thing. But when we actually work out the long division, we're going to be working it out the old school kind of elementary school way that we learned it to do it just with numbers. G of x goes on the outside, f of x goes on the inside. The most important thing with polynomial long division, f of x and g of x can look really complicated, but all it is a three-step process. We're going to divide, multiply, and subtract. And we're just going to do this over and over and over again until we can't do it anymore. And luckily it only takes 2, 3, or 4 times to go through this little process. And we're done. And I'll show you an example so that you know when you're done, you know when to stop. But during the dividing step, this is the most important piece. During the dividing step, you only use the leading term from each polynomial. And that's going to make it's going to make it a lot easier. You don't have to worry about all the other junk that you see. Just the leading term for g of x and the leading term for f of x. But when we multiply and subtract, we're going to use everything. So as an example, and I'm going to do just a very, very simple one. If I want to figure out what x squared plus 9x plus 10 divided by x minus 1 is. X squared plus 9x plus 10 divided by x minus 1. So I'm going to write x minus 1 on the outside and x squared plus 9x plus 10 on the inside. And I'm going to run out of room here, so I'm going to have to switch to another piece of paper. But I'm going to write the same thing on the next one, and we're going to start from there. So we have got x minus 1 going into x squared plus 9x plus 10. We're going to divide, multiply, subtract. That is the order of our 3 steps, and then we just do it over again. And when you divide, you're only using the leading term on each polynomial. So on my divide step, I'm only looking here and here. And we're only dividing those 2 pieces. And sometimes off to the side, I like to do my own little division problem here. The first step is asking me to do is figure out what x squared divided by x is. And we can simplify that with just laws of exponents. That's just an x. So that's what goes over here. So that's my divide step. I divided the first term inside by the first term outside, and I got an x. Now the next thing we have to do is see how much of this polynomial got used. So I'm going to multiply down and subtract. And subtracting will tell me what I have left over to keep working with. So I'm going to multiply my x by both of those pieces and write the answer down here. So x times x is x squared. X times negative 1 is minus x. So that's our multiply step. When we multiply, we use both of them. Now when we subtract, we use everything as well. And all I did right now is write down the exact multiplication. To subtract something with multiple terms, you really need to distribute the subtraction to each term. So that's going to change all the signs here. So I'm going to change that to a minus and a plus. If you did your division correctly, that first piece should always cancel away. And then from there, we'll just combine like terms. So now I have 10x plus 10 left to work with to keep going. Do my divide, multiply, subtract again. So now I'm going to take my first term and my first term and divide those. And off to the side, if you want to, you can write 10x divided by x. And that simplifies to just 10. And it's a positive 10. So this is going to go up as part of our answer. And we're done with the divide step. And now we need to take that 10 and multiply down to see how much of our polynomial got used. So we're going to do 10 times x is 10x. And 10 times negative 1 is negative 10. And we need to subtract this. So both signs are going to change. If you did it right, the first piece should be gone. And then from there, you just combine like terms. And now we're ready to continue on. So take the first piece and the first piece, and really the only piece now, and off to the side, you can write it as a little division problem. And you'll notice that we can't simplify that. We're interested in simplifying this to a non-fraction. And this can't be simplified because there are no x's in the top. This tells me that we're done. So this 20 here at the end is the remainder. And there's a couple ways that we can write this. We can say x plus 10. This division problem is equal to x plus 10, remainder 20. We can also say we still have one more division problem to do, but it doesn't turn out nicely. We still have to divide 20 by x minus 1. So we can also say x plus 10 plus, there's another piece here, 20 over x minus 1. And we weren't able to do that division. It doesn't simplify nicely. So we just take that remainder and divide it by that original divisor. And this is more commonly the way that you're going to see that they want it now that we're in an advanced algebra class. Back in elementary school, we were able to do division and just say 5 remainder 2. But now we want to keep it as one full equation and not have this separate little piece tacked onto the end. So what this means, and this is called the division algorithm. My original polynomial, x squared plus 9x plus 10, is equal to x minus 1 times, there's x plus 10, and then we have to add 20 more in, which was our remainder. So this is called our dividend, and it was the stuff inside. This is called the divisor. It's what we're dividing by. The answer, at least the part of the answer that worked out nicely, was called the quotient. And then we've got this remainder. And this is the division algorithm. And the division algorithm is really not that important. The most important piece is being able to do the division and write your answer like this. So one thing I want to point out real quickly before we move on is that this division problem had a remainder. And when you have a remainder, that means that our divisor does not equally divide our dividend. That means it's not a factor. So because we have a remainder, because it's not equal to 0 in the remainder, that means that x minus 1 is not a factor. When we factor, we want to be able to make our polynomial perfectly without any of these extra little remainder pieces at the end. And this is part of the factor theorem that we'll talk about more in just a little bit when we start getting into synthetic division. I want to work this exact same problem. Now that we know what the answer is, I want to work the exact same problem using synthetic division. That way you can see the kind of numbers we're using in the synthetic division and what all those numbers mean, since we actually already have done this problem and know the answer. In synthetic division, the divisor has to be linear. What you're dividing by must be linear. We cannot do this if the divisor is quadratic or cubic or quartic or anything like that. It will not work. So, again, if we're asked to calculate x squared plus 9x plus 10 divided by x minus 1, what we're going to do is we are going to take our divisor and set it equal to 0 and solve. And this gives us a special number to work with in synthetic division. And I'm going to be using this number over and over and over again, just like I used x minus 1 over and over in every single step when I did the multiply and subtract. So I put it in the top left corner, I put a little box around it just to separate it from everything else. Next to the 1, I am going to write the coefficients from my dividend, just the coefficients. So my coefficients are 1, 9, and 10. And I'm going to leave some space because we're going to write something else here, but then I'm going to do a line. With synthetic division, the first number just automatically drops below the line. You don't do anything to it. After that, though, we're going to take any number below the line and multiply it by the number in the box. So this number up here really means times 1. So 1 times 1 is 1. And then to get the new number below, we add. 9 plus 1 is 10. To go up, we multiply by the number in the box. 10 times 1 is 10. And then the new number below the line, we add, and we get 20. So we started with a quadratic equation. When we do synthetic division, the answer will always be 1 power less. So this answer is linear, and the last number is always the remainder. So these are the coefficients for a linear polynomial, 1 and 10, and 20 is the remainder. So this must be 1x plus 10, and a remainder of 20, we like to write that as a fraction of the remainder over the original divisor. And usually coefficients of 1, we leave those off just to make it simpler. So x plus 10 plus 20 over x minus 1. So we see the numbers we're getting down here are the coefficients in our answer, and it's always 1 power lower than what we started with. So this was quadratic, linear, and constant coefficients. So this is going to be linear, constant, remainder. Everything's 1 power less. And this is the exact same answer we got just a minute ago with the long division.